Do you remember the ball-wheeled bike I built? It balances like a Segway sideways and it can move in all directions. I use 3 omni-wheels per ball so they can be driven any way I want based on the mix of velocities at each wheel. I could lean to go sideways, and I could also drive forwards and backwards or rotate on the spot by driving the balls in various directions, so it was truly omnidirectional. Yes, it's time for the one-ball bike! Is it even a bike or is it just an Ike? Anyway, this time we've got a few more problems, because as well as balancing sideways, like we did with the 2-ball bike, we've got to balance forward and backwards as well, so that needs solving. We also have some problems with steering. With the 2-ball bike, I could just drive the balls in opposite directions to turn, but now I've only got 1 ball, so that needs solving. And we also need to make omni-wheels. There's only going to be 3 this time instead of 6 that we had on the 2-ball bike, so those are going to need to be stronger in order to support the mass of me and the bike and the batteries and everything on top. I have built some single ball balancing robots in the past, but they weren't as good as I wanted them to be. But the 2-ball bike worked really well, and that was due to a fundamental reason. Generally, in ball balancing robots, the wheels are oriented so they're horizontal. Although they're angled, the face of the wheel faces the ground. This caused some issues with the wheels fighting each other at high velocities because the small wheels around the Omni wheels became overwhelmed, so the wheels tried to turn the ball in opposite directions. In the ball bike, however, I turned all the wheels around 90 degrees, so the face of the wheel is vertical. This means that we can apply higher velocities, but of course we can't turn in yaw, which is the vertical axis, so we can't turn on the spot. And that's because there are no driven wheel axis to do this, only the small passive wheels around the Omni wheels. The ball bike had 2 balls though, so I could just drive each ball in opposite directions to turn the whole thing, but I can't do this with only 1 ball, so I'll have to think about steering later on. And yes, I have a plan. Also, last time I used off-the-shelf Omni wheels, but the little wheels are just running on brass bushings, which meant that they actually got hot due to the friction after prolonged use, which made the rubber go soft and then they lost traction. So this time I'm going to make my own custom Omni wheels with bearings in the little wheels. And that's why it's not good at high velocity, because the wheels pop out. My custom Omni wheels each have 2 banks of 18 little wheels which overlap. Each wheel has 2 bearings, and there are 3 wheels, so that's 216 bearings in total. A massive thanks to Simply Bearings for providing all the bearings for this project. The axles they run on are actually 4mm roller bearings, so those also came from Simply Bearings, as well as some bigger bearings for the actual axles. The tyres on the little wheels are 3D printed in Polymaker Polyflex TPU90. I considered 3D printed rigid cores and also TPU95 cores for better impact resistance, but in the end I ordered custom made aluminium cores for the little wheels. Each core and tyre has a corresponding profile so they lock together, and these are a very tight fit. And each one of those cores and tyres has a bearing inserted each end, just like a skateboard wheel, and an axle inserted through that, which are the 4mm roller bearings. I want to make sure these wheels are strong enough to support me, and I also want to 3D print some of the parts to save on machining costs. So I'm using Polymaker Polymax PLA here, and we've got a hybrid approach, so we've actually got an aluminium core that supports the axles of the wheels, and all of the 3D print does is hold those axles in the middle. You might have noticed a washer either side of the wheel, and that means it runs perfectly in the middle. And of course, each of those wheels has 18 little wheels, each with 2 bearings, 2 washers, and a 4mm roller bearing axle. On top of that, there are 2 rows of wheels on each big wheel, each with 18 little wheels, and of course each one with an aluminium core and 2 sides. So there's my completely built wheel, which is bolted all the way through the middle, and that means it can be driven in one axis, where that 40/40 extrusion is, and it can slide freely in the other axis, and that's the basis of most ball balancing robots. So this wheel feels quite solid now it's together, which I'm pretty happy with. I'm a bit concerned because what we have with Omni wheels, of course, is a cutout that's square for the wheel, which means there's always a little thin bit where we have to attach the hub essentially to the rest of it. So these are 6000 grade aluminium and they're 4mm thick, and of course the load on the wheel is going to be right on those edges where the axle is. So hopefully these are strong enough. Maybe I should have had them made of steel, and hopefully the PLA sides, which are all Polymaker Polymax PLA, should be strong enough to hold the axle in the middle. So we'll have to see if basically these little wheels will hold my entire mass between the 3 big wheels, or whether they just break. But we'll see what happens for now. And yes, I've made this whole thing 3 times, so we've got 3 wheels. So now we need to think about some way of driving them. If you've watched my videos, then I've used this solution before, which is the O-Drive branded brushless motors, which are 100 kV, and the O-Drive S1, and the whole thing comes as a kit. So we've got a motor driver that fits on the back of the motor, there's a magnet on the motor and an encoder on the motor driver. The kit comes with the mounting plates to mount everything together, so I've got 3 of those, and each motor's rated at a maximum of 2 kilowatts. We do need some mounts, of course, to hold the axles, so I'm using the 1.2mm nozzle here to print Polymax PLA again to make some really big chunky parts, and those should be really tough and able to support my mass on those 3 wheels.
Thanks to Polymaker for supporting this project with 3D printing filaments. All these parts printed with a 1.2mm nozzle, the Polymax PLA, as are the other parts printed with a finer nozzle, and I've made these parts so they interlock, so we've got the finer one holding the motor, and then the main axle is printed with the really big extruder.
I made these shim parts also with the finer nozzle, which fit into the 1.2mm nozzle prints, and that means that I can tolerance them separately for any bearings and things that have fine tolerances. So that means the bearing fits perfectly, and I only have to print the red part again if it doesn't, rather than that whole massive part. So we've got bearings that fit in there, and that's where the axles are going to run, and you may notice there are bearings back and front. So lots of bearings that should hold that axle nice and tight. And then we've got a piece that fits in there so we can put our square axle in the round bearing. These are the pulleys for the motors, and I'm putting self-tapping screws right through the build lines to reinforce the parts so they don't snap. And each one of those is screwed onto the flange on the brushless motor. In both the previous bull bike and the screw bike I had an intermediate pulley with a slight reduction on, but it isn't actually much of a reduction, and basically ended up just being a bit of a belt converter from the 2 different size belts, so this time I'm not going to bother and I'm just going to go straight on from the motor onto the pulley on the wheel. So this is the new bike, and this time it's a lot simpler. We've just got the pulley on the motor, a pulley on the wheel, and we've got a belt which goes between them. And that's going to be it. And these are 610mm long belts, and they are HTD 5M profile, which is a 5mm pitch, and they should be really, really tough. The chassis is going to be built out of 40/40 extrusion because basically it's a box section, and it's also really, really easy to bolt stuff together with T-nuts that you can put in the slots and metal brackets. The screw bike chassis was welded steel, but this is a much simpler solution and it's really easy to put together.
So that's my main chassis, which is very, very rigid, made of all of this box section 40/40 extrusion and all those aluminium plates and brackets. So basically we've got 3 places to mount motors, which are here, here, and then here, and the ball's going to sit in the middle. Whole thing goes that way up, and then that should make up the main structure. So let's put the rest of the gearboxes together.
So all 3 wheels are mounted and all 3 motors are mounted, and they've all got those belt drives that seem to run really well. The belts are quite tight, although I did leave provision for idlers. There's some extra holes for some axles if we need to pull them tighter. And the motors themselves have a bearing in the end of the pulley that's also braced on another little bit that sticks out, and that means that that belt remains tight and everything remains square, with both the axle and the motor braced at both ends. Everything is bolted together with M5 bolts, and I put washers on the other side of the prints where I can. There's also some threaded inserts in the top of those parts, and I've got these little caps that go on that help also attach from the threaded insert to the extrusion. There's one on each side there and a plate on the back to hold it square.
So obviously that goes in there. So I put these bits of blue tape on here so we can see the ball turning, otherwise we can't see it moving because it's just red. So if we rotate the ball in here, if I move it this way, then we should be able to see all 3 wheels turning. Obviously this one is straight and rubbing on the ball, and then these 2 should both move in the same direction to move this along. Now we need to work out the wheel ratios, the speeds basically. It looks like the back one's actually going faster, which is weird, but we'll sort that out in a minute. If I rotate it the other way, so this will be sideways travel for the bike, then the back wheel doesn't do anything, only the little wheels are passive and they roll on the ball, and the other 2 should move in opposite directions, and that'll be the sideways motion. However, if we spin the ball, none of the driven axes turn at all, and that's because the ball is just rubbing on the little wheels, which means we can't drive the ball in yaw, and I'm not sure if that's going to be a good way to turn even if we did. Okay, so I put some blue markers on the wheels here that mark the top, and then we're going to push this along, and I'm going to keep as straight as I can with the lines in my tiles here. And we'll see what the ratio is between these 2 wheels. So Well, that's one revolution on the back wheel, but that's only gone round half. Let's do another one. So this has gone round twice, and this one's gone round once.
And that makes some sense, because if we work out the trigonometry, the cosine of 60 degrees is 0.5. I was expecting the two wheels that are at 60 degrees to need to go faster though, because it looks like they'd need to go faster to catch up with the one that's facing straight. That's not the case though, and I guess that's because lots of the velocity is taken by the perpendicular little wheels that can spin as freely as they like. Now we know the proportions of the wheel velocities to each other, we can drive them all in sync properly.
So obviously this thing goes the other way up with the ball on the bottom, and I'm going to ride on the top. So I'm not sure which way I want to ride it really. Obviously we've got these three wheels, two in this kind of cross configuration, and then one at the front. So it might make sense to sit on it this way, and I really need to make sure that I've got my mass over the middle of the ball, otherwise I'm not going to be able to balance. But I don't really want to have handlebars here and my legs stuck, so if this falls backwards or something, I'll get stuck in it and I can't get out. So my original design was to ride it a bit like a sports bike where I'm leaning forward, so having these two wheels in front of me and one at the back, and then I can kind of slip on and off the back here, like this, with a saddle, have the handlebars really far forward, and then I should be able to get my mass over the ball, so... Whoa! Yeah, it might still be a problem falling forward. But actually I feel like I can balance much better and I can still get my legs either side of the ball. So that's not going to be so much of a problem. Right, let's build some balancing electronics and see what happens. But before we see if this project's going to work at all, it's time for a quick ad from a great new free STEM project website called ArcSTEM. YouTube and other social media can be great for inspiration, and although I show how I build my projects in my videos, not everybody does. ArcSTEM is a one-stop shop for submitted projects and also the project progress, documentation like code, a list of the parts used and methods used in the builds. It's a dedicated space for innovators, robotics enthusiasts and STEM students to move beyond the mindless scrolling of social media. It's a focused community that prioritises intellectual curiosity over viral trends. All the information is in one place, so you can get truly inspired by the projects and even recreate them yourself. There are also lots of projects in progress on ArcSTEM. Rough and ready ideas are evolving as creators crack one challenge after another, fighting through setbacks, escaping dead ends and unpicking technical puzzles. Register for free and check out the project tab, which highlights dedicated project pages that allow creators to document their build from concept right through to execution, while interacting with the community through the comments section. I really like the Heart Reactor by Matteo Tech Lab. It's an Iron Man arc reactor which is linked to the wearer's heart rate through a smartwatch. You can check out the video and all the details now. ArcSTEM is built for meaningful dialogue between makers and enthusiasts and as a hub of technical mentorship. You can register for free to check out the projects and submit your own. Head over to the ArcSTEM website or download the app and sign up to a community of like-minded makers for free today. Right, let's get some electronics built and see if this is going to work at all.
First of all though, we need some power distribution, so I've got 6 6S LiPos which I'm going to run in series pairs to give me 50 volts and run all those pairs in parallel for more capacity. We can use a big contactor which is a relay to turn everything on and off with an emergency stop on the control panel. The batteries live underneath the front there with all of their tails poking out where the contactor is, so they're easy to wire in. And I'm using these wire adapters to wire series pairs, so I get 2 in series for 50 volts. And those suspicious looking bolts combine the series pairs in parallel, so there's 6 series pairs in parallel. There is another 12 volt battery to power the contactor, and normally I use that to power the headlight as well. There is yet another battery to power the electronics, which is one of these MP batteries that's used in lots of production equipment, so that powers the low voltage via a voltage regulator inside that box. We've also got a Teensy 4.1, which is the main controller, and a B&O 086 inertial measurement unit to measure the angle so we can make it balance. And there's also a CAN bus transceiver in there. This time I've sprayed the inside of the box with nickel screening spray, and that makes it conductive, and I'm shielding for static electricity. Last time I had a lot of funny glitches with the big plastic balls, rubber wheels and brass bushings that caused a lot of weird glitches, which I assume was static electricity affecting the electronics somewhere. The inertial measurement unit gives us roll and pitch and yaw data. This time we need just the roll and the pitch because we're balancing in 2 axes, and then we're going to make a response to drive the wheels. I'm using a PID controller for this, which I've covered a number of times before in various other projects. There's an Arduino library for it too, which makes it super easy. There are 3 terms which need tuning. The first is proportional, which means as the bike leans more, the wheels are going to get faster, but that's not enough to make it balance on its own. The most important term is the integral term, which is easy to understand by imagining the area under the graph. If the angle of the bike is constant and time progresses, the area gets bigger, so the wheels accelerate. If the angle increases, then the area gets much bigger, so there's even more acceleration. This may cause overshoot and oscillations though, so the derivative term makes the sharp tangent response to the curve of the angle, so we can use it for damping. Tuning the PID controller is a bit like focusing a camera with 3 lenses, and they all get mixed together, so everyone has to be perfect. But I've got quite good at making large balancing robots since I've done about 4 or 5 balancing bikes, so I know roughly what the parameters should be, and I can look at my old code for the other ball bike in any case, and get it just roughly right. I've tuned it so the bike is leaning back because the heavy batteries at the front will pull it forwards otherwise. But I have 2 controls so I can fine tune the roll and the pitch and get it to sit right in the middle, and of course I'm going to need to vary those when I get on and get my mass over the ball.
But the question is, can I ride it? Let's put the seat on. Whoa, right, so let's just trim that forward a bit to get my mass over the ball. A little bit more. Could really do with some handlebars to put my hands in front here and some foot pegs, but actually that balances me quite well. Oh, okay, so if I lean a little bit, yeah, I can drive, but I really want some controls to add some velocity to the ball and probably a little bit of set point so it leans as I go. Let's try sideways. So that's a bit like the ball bike, but we're still going to have a control for that as well. And then hopefully I can lean to steer by going forwards and leaning to the left or right, and it should bank, I think is going to be the plan. But that is supporting me quite well, and I definitely need some foot pegs and some handlebars in front of me. But that's looking pretty good. Hey! Yeah, this is going to be super fun.
The controls for this are basically a twist grip which I designed in the 2-ball bike, so have a look at that video for more information. This has basically a centre point with 2 sprung fingers that keep it there, a Hall effect sensor in the bottom where the wires are attached, and 2 magnets which move closer or further to it on each side. Then we can sense the distance and use that to drive forwards or backwards or left and right. And yes, of course, there are 2 of those, one on each side of the handlebars, which has a steel rod all the way through so I can put my mass on it. That's mounted on the front of the bike, and I put these big bumpers in front of it in case it falls forward so I don't smash the twist grips up. I made an attachment for the back, and some 2020s fit perfectly into the 4040. On the bottom of there is some foot pegs, and that's removable so I can put the whole thing down if I need to. So now I've got a handle on my right hand side which when I twist it varies the angle it wants to balance at forwards and backwards and adds up to 10 degrees or minus 10 degrees to it, and that means I can use it as well as leaning my mass to drive forwards and backwards, or I can use it as a brake to suddenly make me go the other way. And I've got the same sideways, although it's quite hard to drive directly sideways without leaning forwards and backwards at all, and the plan is to mix all of these together to steer. If you imagine a ball with the sides cut off, then it's just like a wheel. So all we have to be able to do is lean the wheel, or the middle part of the ball in our case, to steer like any electric one-wheel personal transport device. Hopefully, if I can drive forward and then change my PID set point to lean to one side, then it should bank and make me turn.
We're going to need a bigger testing area. Right, so I can balance on the spot okay, but I've never driven this in a big space, so first of all I've got to get some confidence learning to drive it and just try and get to grips with it and see what its velocity limits are. So I'm just going to try drive in a circle, just leaning, not even using the twist grips. Ugh. It's actually quite responsive. Oh. Definitely need to keep my mass above the ball. For some reason it's turning anti-clockwise and I'm not sure why. Ooh, I think it goes faster than that. And I don't know how fast. Still haven't got to the top speed, at which point it won't balance anymore, so I've got to be quite careful. But it's quite fast. It's a little bit scary. I don't know what happened there. Something made a sound. I might have leant on the e-stop. I leant on the e-stop. Well, at least we know it works. So all of that was with no twist grips. That was just by leaning, which is actually quite a natural way of riding. I guess that's the same as a one wheel or anything else. If I use the twist grips, it actually feels quite sketchy because it's affecting the point at which we're balancing, the angle. So you really need to lean at the same time. But then it feels like it's going to overbalance, even though I can adjust the scale of them. It's good for sudden stops, but actually I don't really feel comfortable with them. I'd rather just lean my mass around, and then I feel like it's actually quite controllable. And that's a much better way of driving.
So now it's time to try and lean to steer as I'd planned.
No, it's not steering the way I want. Come on. No, it's turning the wrong way. Why is it doing that? No, it's just uncontrollable. So I can spin really freely on the spot, so I think even if I could rotate the ball with a motor, it wouldn't have much traction and it'd be really hard to start and stop. But because it rotates so easily on the spot, I can use this board to push me round. So what we need, I think, is some flight control surfaces, like a Star Wars speeder bike. I don't think this is really big enough, though, to do it while I'm driving.
So it's time to get the hot glue gun out, a piece of wood and a really big piece of foam to make a much bigger wing to hopefully blow me round as I drive.
It's a bit of a big flight control surface, but let's see if I can get enough air resistance to turn. Right. Oh yeah, okay, it's turning left. It did turn left anyway though, so we'll try the other side in a sec. But I think that's turning left more than it was. Let's make the stick longer. I think it's working. What? I didn't hear the E-stop that time. It doesn't take much to pull me around, it's so light. We don't need much. I think we could just use some fans. Probably not a massive flight control surface, but you know. And I'm leaning slightly into it and that's helping as well, so it kind of is leaning to steer. Yeah, it doesn't take much to turn it, ridiculous as it is.
So now it's time to push it, build up confidence and see how fast it would really go.
Oh, there we go, look at that.
Now, there's a weird glitch just here, and you'll also notice my hair's getting full of static. Now, I had lots of problems with the plastic balls on the two-wheel bike with static electricity, so I think that might be what's causing it to cut out.
No.
You'll notice just here it's still turning anti-clockwise, but then a bit later it starts turning clockwise. So I think there is an aspect of lean to steer, but it just takes a lot of distance travelled to make it do it, and I'm not really in control of it.
I feel mildly terrified. Come on, come on, come on. Well, it definitely goes. Whoa. Alright, really using those twist grips now. Push it. God, it bloody goes as well. Oh yeah, they're really good for braking actually. Whoa! Ah! Right, that's the end of part one. There's going to be a part two for making it steer. Yeah, I think so.